Student, welcome back to Organic Chemistry with your tutor Himn Hassan. This lecture is dedicated and present to the University of Comar for Science and Technology, College of Medicine, Department of Pharmacy, second year. Today we are talking about diene. Actually, diene is not a separate chapter from alkene and alkyne because it has similar properties and chemical reactions like alkene, and it can be one of the methods to preparation of alkyne. But why I am studying this subject as a separate chapter? Because it is essential and important in nowadays researches in drug discovery and developments. As you can see here, I have 4 examples. They are all dienes. So let's recognize what is diene. If you see this double bond here and the double bond here in the same structure of jasmine, in the same structure I have 2 double bonds. Okay, means I have diene, means I have 2 double bonds. That is how we name it diene, from double alkene in the same structure. Diene means double alkene in the same structure. Or carbon, our carbon has the same structure. Oximine has a double bond, 2 and 3 double bond actually. Aconitic acid, 1 double bond, 2 double bond. But please remember, one of the double bonds are not alkene like double bond. It is OC double bond, carbonyl. So let's go deeper. The structure and nomenclatures of diene. Basically, their chemical structure is similar to alkene, apart from having 2 double bonds. Means 2 pz orbitals, 2 couple of pz orbitals have overlapped together and they have formed 2 double bonds. As you can see here, from the down right side of the picture, you see a double bond and another double bond. Between them I have a CH2. These 2 pz double bonds of adjacent carbon atoms formed a pi bond. Here I have a pi bond, and on the other hand I have another pi bond. Why it is written here isolated? Because these 2 pi bond have nothing to do with each other. So let's study the other one, conjugated diene. What does it mean conjugate? Means I have a double bond here, a single bond in between, a double bond next to it. So whenever I have double, single, double, this means conjugated. Conjugated means they have something to do with each other. Means the first double bond can affect or interfere the second double bond, especially in transition state. While isolated diene, they can't do anything with the other double bonds. Why? Because they are far from each other and they have a CH2 group that isolated the 2 pi bonds from each other. And we have cumulated diene, means the 2 double bonds are exactly next to each other. Means I have a carbon, a double bond, another carbon. The carbon here is number 1, carbon 2. On carbon 2 I have another double bond with the carbon 3. This is called cumulated, and in modern research organic chemistry we called that allene. It's a beautiful name, allene, ALLEN. Okay, this is the nomenclature. We have 3 types of diene: isolated, conjugated, cumulated diene. These dienes are different in their stability. When we are talking about stability, as much as a molecule will be stable, it should have less potential energy absorbed between the bonds and the molecular structure. When we are saying this molecule is unstable, it means this molecule has a greater amount of potential energy absorbed between the bonds of the molecular structure. I know you are thinking that which one is more stable and which one is less stable. So actually it depends on the rest of the chemical structure. But usually alene is the less stable one. Conjugated diene is the more stable one. According to IUPAC system, we have three types of diene: cumulated, conjugated, and isolated. The conjugated diene could have a cis or trans structure. In that case, the double bonds are representing. We are considering these two carbon as a center, and that side is down, and that one is up. This double bond number 1 is down, double bond number 2 is up. That is why we are saying trans. But why we are saying here trans?